The 12th chapter is exponents and power. So first of all, I introduce about the exponent and the base. Here you can see this introduction. In introduction, the mass of earth is 597 and 000 up to 22 times. Okay, so this is the largest number. So how can we write such a large number into a easiest way? Okay, so first of all, we take this 0 as a 10 raised to the power 24. Here you can see this 10 raised to the power 24. So how can we read this 10 raised to the power 4? So first of all, 10 raised to 24 power is read that 10 raised to the power 24. Okay, in this example 10 is a base, 10 is a base and 24 is a exponent. So we can read this as a 10 raised to the power 24. The distance from the earth to the sun is about 15 crore 29 lakh kilometer. It takes 4.3 light year at the speed of 2,99,792 kilometer per second, and which is equal to like this. Okay, so it is a very difficult to read and write. Okay, that's why we take a help of a exponential notation or exponential form. Here is the another example of exponential form. First of all, what is the exponents? So here you can see this, the example is 5 cube. We can also read this as 5 raised to the power 3. So in this example, 5 is a base, 5 is a base and 3 is a exponent. So what is the exponent? 3 is a exponent, and all form 5 raised to the power 3 is called a exponential form. For example, 125, we can write 125 as a 5 cube, because 5 5s are 25, 25 5s are 125. So we write 125 as a 5 cube. That means 5 cube is an exponential form of 125. It means 5 cube is an exponential form of 125. So 5 cube means 5 raised to the power 3, means the product of 3 factors of 5. Here you can see this 5 raised to the power 3 means the product of 3 factors of 5. We can write, it means we can write a 5 as a 3 times, so is equal to 5 multi 5 multi 5. So this is the exponential form of a 5 cube, where 5 is a base and 3 is a exponent. Take an exponential form. So how can we write a large number into an exponential form? So here you can see this exponential form is a shortcut for writing a repeated multiplication by the same number. Again I read this, exponential form is a shortcut for writing a repeated multiplications by the same number. For example, here we take a 5 as a 4 times. So how can we write these factors into exponential form? So here we can write 5 raised to the power 4. Here you can see this 5 multi 5 multi 5 multi 5 is write as a 5 raised to the power 4. In this example, 5 is a base and 4 is a power. In this example, again I repeat this, 5 is a base and 4 is a power or exponent. Again we take another example. If here we take a 10 multi 10 multi 10 multi 10 as a 12 time. Okay, here we take a 10 multi 10 multi 10 as a 12 time. So this is the easiest method to how to write 10 raised to the power 12. So here we can write 10 raised to the power of 12 like this, 10 raised to the power 12. In this example, 10 is a base and 12 is a power. In our first example, we write 5 raised to 4 as a power. So here you can see this 5 raised to 4. So in this example, 5 is a base and 4 is a exponent. Exponent, or we can also exponent as a index, power or order, but generally we call is as a exponent. So it's called a 5 raised to the power 4. 5 is a base and 4 is a exponent. So how can we simplify 5 raised to the power 4? So we take a 5 as a 4 times, 1 2 3 and 4. We know that 5 5s are 25, 25 5s are 125 and 125 5s are 625. So this is the simplification of 5 raised to the power 4. Here are the some example of exponential form of an algebraic expression. Here you can see this all are the algebraic expression. In our first example, we see that a is as a 3 times, a multi a multi a. So we can write as a raised to the power 3. In our second term, we have a b multi b. So we can write as a b square. In our second example, we have a y as a 3 times. So we write as a y cube. and in our second term we have 4z, so we write as a 4z, and in last term we have a y, so we can write as a y. In our third example we have a in bracket x. X is a 1, 2 and 3 times, so we write a x cube. In our second term we have a b multi x 2 times, so we can write a b x square. In our third term cx, so as it is we write a cx, and in our fourth term we have a d, so we write as a d. So this is the examples of in algebraic expressions into the form of exponential. Here are the rules of exponents or laws of exponent. First is multiplication rules. In these rules, if we take a raised to the power x multi a raised to the power of y. First of all, here we can see this in our first term and in our second term, both term has same base. In our first and second term, both term has the same base as a, but the power is different. Power is in our first term power is x, and in our second term power is y. But according to our rules of exponent, whenever the base are the same in a multiplication operation, so we have to take the addition between their power. Okay, so our answer becomes a raised to the power x plus y. So this is the first rule of multiplications. Now we take our second rule, division rules. So in these rules we can see this a raised to power x divided by a raised to the power y. First we check the base. So in these rules both base are the same as a, but here we have to take a division operation. So whenever we take a division operation, we have to take a subtraction between their power. According to our rules, whenever we take a division operation, we have to take a subtraction between their power. And again I repeat that whenever we take a multiplication between the same base of power, so we take the addition between their power. So in a multiplication rule, the base are same, so we take the power addition between their power. And in division, whenever base are the same, so we take a subtraction between their power. Third is power of a power rule. In these rules, here we have a raised to the power x, but a raised to the power x whole power is y. So we have to take a multiplication between the two powers x and y. We have to take a multiplication between x and y. So our final answer becomes a raised to the power xy. So this is the rules of a power rules. We have to take a multiplication between two powers. Fourth rule is a power of a product rule. Fourth rule is power of a product rule. Here you can see this ab in a bracket ab raised to the power x. So what can we do? So in these rules we have to take a power individually. Here you can see this ab raised to the power x. So on our right hand side we have to take a individually power like this, a raised to the power x and b raised to the power of x. So in the rule of a power of a product rule, we have to take a individually power into the both term. In our fifth rule, power of a fraction rule. In our fifth rule, power of a fraction rule. Here you can see the fraction is a divided by b. Fraction is a divided by b and the whole power is x. In this fifth rule, fraction is a divided by b and the whole power is x. So in these rules we have to again take a individual power like this, a raised to the power x divided by b raised to the power x. Next rule is zero exponent. Next rule is zero exponent. This is the most important rule. Whenever we have a power as a 0, our answer becomes 1. Whenever we have a power as a 0, for example a raised to the power 0, our answer becomes 1. So this is the important rules. Zero exponent, any number has a power as a 0, our answer becomes 1. So a raised to the power 0 is equal to 1. And last rule is negative exponent. In this rule, if here we have a raised to the power minus x. So first of all we have to convert this power into a positive. Okay, so we can write a raised to minus x power into a denominator. So here you can see this, we can write a raised to minus x power as 1 divided by a raised to x. We can write a raised to the power minus x as 1 divided by a raised to x. So on our right hand side a raised to x becomes a denominator. So on our left hand side a raised to the power x is negative, but we take on our right hand side a raised to the power into a denominator, so it becomes a plus. So in our negative exponent we have to convert this term into a positive exponent as convert into a numerator to denominator. Again I repeat the zero exponent. Here you can see this a non-zero base raised to a zero exponent. Again a non-zero base raised to a zero exponent is equal to a 1. For example, here we can see this a raised to the power 0 is equal to 1. There are another rules of exponent or power. First is a raised to m multi a raised to n. We already discussed this. A raised to m multiply a raised to n. Whenever we take a multiplication operation and base are the same, so we have to take a addition between their power. Next is a raised to m divided by a raised to n. We also discussed that whenever we have a base as the same, so in a division operation we have to take a subtraction between their power. So here you can see this a raised to the power m minus n. Next is a raised to m and whole power n. Here you can see this a raised to m and the whole power n. So we have to take a multiplication between the two powers. So final answer becomes a raised to power m n. Next is a raised to m multiply b raised to m. This is the important rules. Here you can see this. In these rules, a and b both the base are not same. Again I repeat this. In this example, a raised to the power m and b raised to the power m, a and b both are not same. Both are the base and base are not same. But the power, here you can see this power m and power is m. In our first term we have a power m and in our second term we also have a power m. So both the power are same. So what can we do? So in this type of example we have to take a multiplication between a and b, because here you can see this the relation between a and b is a multiplication. So here we take a multi b and we write both power as the same. We can write both power as a common power. So our final answer becomes ab raised to the power m. Our final answer becomes ab raised to the power m. In these rules again we can see this a raised to the power m and b raised to the power m. In this example a and b both are the base and base are not same, but their power a raised to the power m and b raised to the power m both the power are same. So we can write as a common power m. We can write m as a common power. So our right hand side becomes a divided by b raised to the power m. Our right hand side becomes a divided by b. Why we can write a divided by b? Because on our left hand side we have to take a division operation. That's why on our right hand side we can write a divided by b as a base and m as a common power. Next is a raised to the power 0 is equal to 1. We already discussed these topics. A raised to power 0 is equal to 1. Next is a raised to power minus m and b raised to the power minus n. In this example, here we can see these a and b both are the base and base are not same, and also a's power is minus m and b's power is minus n. So also power is also not same. So what can we do? So first of all we have to convert this negative power into a positive power. So we can write a raised to the minus power m into a denominator, and we can write b raised to the power minus n into a numerator. So it becomes a plus. So what is the answer of a raised to the power minus m divided by b raised to the power of minus n? It becomes a b raised to the power n. Power becomes positive, and in a denominator a raised to the power m, also the power m becomes positive. Divided by b raised to the power minus m. So first of all we have to convert this negative power into a positive power. So first of all we take a reciprocal. In this example, a divided by b, we take on our right hand side b divided by a, because on our left hand side the power of m is negative. So whenever we take the reciprocal of a divided by b, it becomes b divided by a, and the power becomes negative to positive. So the answer of a divided by b raised to the power of minus m becomes b divided by a raised to the power m.